Welcome to our lesson on factoring special products. In this lesson, we'll be learning how to factor perfect square binomials, such as a plus b, the quantity squared, or a minus b, the quantity squared. We're missing a squared there. So let me draw that one in. That should be squared. Sorry about that. And then also to be able to factor a difference of two squares. Now notice the difference, a squared minus b squared, that's not the same as this a minus b, the quantity squared. So I just wanted to point that out. So let's start off with the special product where we have a sum of two numbers squared or a difference of two numbers squared. When we have the sum of two numbers squared, that works out to be the square of the first one. And then we multiply and double those. So if we multiply a times b and then double it, we get plus 2ab. And then lastly, we square the last one. So we talked about how to expand this or how to multiply this using FOIL, and this was our shortcut where we square, multiply, and double and square, and that's the significance of the squares and the MAD up in the title there. And then the one that is the difference of those two numbers is a squared minus 2ab plus b squared. So they're very, very similar. The only thing different is that negative sign or the positive sign. So these are called perfect square trinomials. We're going to start with the trinomial and work to factor it and get the binomial square. So when we factor a perfect square trinomial, we get a single square binomial. So let's go ahead and look at what this looks like with some practice problems. We want to figure out if these polynomials are perfect square trinomials, and if they are, we want to go ahead and factor those. So let's take a look and see. Well, we can see that the first term is a perfect square and the last term is a perfect square. And this last term, if we take the square root of 49, we would get 7, right? So the thing we need to ask ourselves, if we multiply 7 times x and double it, do we get 14x? And we do. So we would want to write that as x and 7, the quantity squared, and then the sign is going to be whatever is on the first sign there will be what's in our binomial. Over on the right-hand side, the square root of 64, if we take the square root of that number, that's going to give us 8. So if we double 8, we do get 16. So this one will factor as x, and because the sign is minus, we're going to have x minus 8, the quantity squared. Over on letter C, if we take the square root of the first term, we get 4x. And the square root of the last term, we get 3. Now when we multiply and double those, okay, multiply, we get 12x, right? But when we double it, we do get the 24x that we're looking for. So this would factor as 4x minus 3, the quantity squared. And then letter D, taking the square root, we get 3x, and the square root of 4 is 2. And so when we multiply those together, we get 6x, and this is double 6x, so this one also factors as 3x and a 2, and our sign, again, because this is a minus sign, that'll be a minus there, and it is squared. Problem number 2 says Frida throws a rock into the center of a lake, and after a second, the area inside the ripple is given by this polynomial expression. How many inches has the radius increased? Well, if we take a look at that thing, pi r squared plus 16 pi r plus 64 pi. Well, all of those have pi in it, so let's factor out the pi and see what's left. And we would have r squared plus 16r plus 64. And then this thing looks like it might be a perfect square trinomial. So pi stays out front, and we're going to have r and an 8, right? And then if we double 8, do we get 16? And we do. So it's r plus 8, the quantity squared. So how many inches has the radius increased? The radius has increased by 8 inches. So this is kind of like pi r squared, right? Where this is the area. The area of a circle is pi r squared. So it looks like the radius has increased by 8 inches there. So now we're going to look at the difference of two squares. And the difference of two squares, a squared minus b squared, is a plus b and a minus b, and it doesn't matter which order you put these. These factors are called conjugate pairs. So let's do some practice on these. Conjugate pairs factoring the difference of squares. Determine whether the binomial is a difference of two squares, and if it is, let's factor it. Well, what we want to do is we want to see if each term is a perfect square. And if we take the square root of the first one, we get 10x. If we take the square root of the second one, we get a 5. And it's separated by a minus sign here. So one of our factors is 10x plus 5, and the other factor is 10x minus 5. Now letter B, 2 is not a perfect square, but we could factor out a 2 because it's a common factor, and we would be left with x to the 6th minus 144. Remember, we're dividing by 2 to figure out what's left. Now both of these are perfect squares, so now it will actually factor as a difference of two squares. So what would the exponent be? What do you think the exponent is going to be here? If we took the square root, we end up taking this exponent divided by 2, which would be an x to the third power. And then the square root of 144 is 12. So we're going to have a plus 12 and a minus 12 in our factors. Letter C, we do not have a difference of square. We have a sum of squares. So we cannot do that one. That one does not factor as a difference of two squares, so we have to leave that one alone. Letter D, we can rewrite that as x to the 10th minus 36. And now we have a perfect square. This is x to the 5th plus 6, and x to the 6th, x to the 5th, excuse me, let me erase that one. X to the 5th, let's redo that one, x to the 5th minus 6. That is pretty sloppy. That is a 5 right there. So this problem number 4 says a large square has an area of 121 square inches. A smaller square has a side length that is y inches. What is the polynomial representing the difference in the areas of the squares in factored form? Well, let me draw a picture here for us. Let me just see if I can pull up a square for us. So we're going to have a small square and a large square, right? Something like this. Hopefully that will work for us. And they're telling us that the large square has an area of 121 inches. Well, remember the area of a square is the side length squared. So if we know this is 121 is the side squared, how do we figure out what s is equal to? Well, to figure out what s is equal to, we have to take the square root of both sides. So when we take the square root of 121, we get 11. So we know that each of these sides is 11, right here on the large square. And then it says the smaller square inside has a side length of y inches. So we know its area, the area of the smaller one, is equal to y times y, which is y squared. Okay? What is the polynomial representing the difference in the area of the squares in factored form? Well, if the first one is 121, so we'd have 121 minus y squared, right? Well, they're asking us to factor that. What would that look like? Well, we'd have 11 minus y and 11 plus y. And that would be in factored form. So here's a nice summary page for you, summarizing the different ways we've learned how to factor so far. I thought this would be a good thing to include for you. And any polynomial, we always want to start out by looking for a greatest common factor. We can see in this polynomial, they both share a factor of a. If we take out a factor of a, we're left with b minus c. Here's an example using actual numbers and letters together. These share a common factor of 2xy. So if we take the 2xy out of each term, we're left with 3x plus 5y. Remember, we're dividing to figure out what's left. The difference of two squares, one of them is the sum of the two numbers, the other is the difference. Here's an example. Take the square root of both terms, and we get x minus 3y and x plus 3y. When we're factoring trinomials, we want to look for perfect square trinomials that we just talked about. So here are how those factor. Remember, if the middle term is double the product, then it factors in this way. Here's an example. The square root of 4 is 2, and if we double that, we do get 4, so this is x plus 2 squared. The square root of 1 is 1, and if we double it, we do get 2, so this is an x minus 1, the quantity squared. Down here, we also have trinomials where sometimes we have the coefficient in front of the quadratic term is 1, or maybe it's bigger than 1. So here are some examples. These don't have a specific way of factoring, but over here we can factor these. This one we want factors of 2 that add to 3, and those are 1 and 2, and they're both positive. This one we want factors of 12 that add to 7, so that would give us a 4 and a 3 for our inside-outside term. So those are the factors we get there. And just as a little review, if we have 4 or more terms, we can factor by grouping. So if I group the first two and the last two, I can factor out an x. If the last two, I can factor out a y. And now they have a plus b in common. So I can factor that out, and I'm left with x plus y times a plus b. Again, grouping the first two and the last two, common factor of 2x squared comes out, and then they both share a factor of x plus 2. So we get x plus 2 times 2x squared plus 1. That will do it for this video. See you in class.